I'm going to talk a little bit about the math curriculum at Jefferson Community School. This is basically our high school curriculum that consists of 4 books, 4 years, and we've adopted the Exeter set of textbooks with such intriguing titles as Math 2, Math 3, Math 4C. I am a math teacher. I know I only have 3 books here, but there is a math one as well. And if you had to label the approach, it's probably a constructivist approach where the student is required to take a lot of responsibility for their own learning. And as a parent, you may be thinking, well, I don't know if I want an atypical curriculum for my child. Oh, yes, you do. Let's take a look at a standard Exeter problem. Given a rectangular prism, the surface area is 95 square units. The sum of the lengths of the edges is 48. What is the length of an interior diagonal? Now, all the students are comfortable and understand the 3-dimensional distance formula. That's not the problem. They recognize that and understand that that would give you the diagonal. But here, the information we're given doesn't explicitly give us any of the edges. We don't know what they are. So how are we going to get to this formula? And that's typical of Exeter. We start and we're a little confused. We don't know exactly how to get there. But one thing students at JCS do know to do is get started. So the first thing they'll do is they'll write down the equations for the 2 given amounts of information. And as Einstein says, you should make everything as simple as possible, but not simpler. So we're going to divide both sides by 4 here, and left with this. Now this is nice. Here's x, y, and z, but they're not squared. And so again, we have these 2 equations. We don't know x, we don't know y, and we don't know z, and still not quite sure how we're going to get there. So the students strategize, and here's where the thinking comes in. Eventually, and if need be, we'll give them a hint, they're going to square this, because they know they'll get x squared, y squared, and z squared out of it. They know there'll be some additional terms, but at least they've gotten that far, and then maybe they'll see something else. So it's this progression. So squaring a trinomial isn't all that much fun, but here's what we end up with. So we've got these 3 terms that we'd like to have, and if these didn't exist, then we'd be basically done. But they do exist, and what are we going to do about that? That's where the inspiration comes in. I don't know if you've seen it yet. I assume that many of the JCS students already have. These 3 terms happen to be the surface area. And so we're going to subtract this equation from this one and take the square root and end up with the diagonal being 7 units long. So that's pretty stunning. We still don't know what x, y, and z are, but we do know the length of the diagonal. We didn't know how we were going to get there when we started, but we kept working at it, tried a couple of different things, and finally had great success. It also opens itself for lots of other explorations. Given 2, we can find the 3rd. So you tell somebody that if you know the length of a diagonal and the sum of the edges, you could find the surface area. I think that's a little, just doesn't seem obvious. Maybe we can find out something about the volume. So take the standard curriculum. Here's the distance formula. Memorize this formula. Do exercises 2 through 42 even on page 156. I may have trivialized that a little bit, but any of you that remember your high school math know you've had to do exercises like that. This is mathematics. This is not. Here you get answers. Here you get solutions. So, seems like a great program. Why don't all the schools use it? Good question, a really simple answer, class size. JCS has the advantage of being able to offer small class sizes. The students here compare strategies, discuss strategies, defend their strategies and their solutions. You can't do this with 30 students. You can't do it with 20 students. I would rather not do it with 15. I think 10 to 12 is about as many as you can do. My wife is an excellent middle school math teacher, but in one of her classes she has 34 students, and this is what they do. It's about all they can do. So you're thinking, okay, so it seems like a decent curriculum, but I don't think my child can do it. Well, you're wrong. They can, and they do it every day. This is what the students do. We see they're all successful at it. It does take a little bit to get started at it. It's hard to jump into book 3 or 4 if you haven't worked through books 1 and 2. Mainly because you have not developed this mathematical method. But the students do it, they like doing it, they discuss, they're involved, and it's a lot of fun to watch. The other thing is they want to do it. Last year my calculus students were from the high school. I'd known them from before. Good students, hard workers, obviously had passed all the prerequisites for calculus, and so I gave them the Exeter 4C book. And it was a bit of a struggle. They just weren't used to this kind of approach, you know, basically a mathematical approach. So I helped them and helped them and helped them. They grew frustrated. I got frustrated. They finally said, "Can't you just like give us show us an optimization problem and make us do 20?" And so I said, "Okay." And we went to a standard curriculum and finished the year that way. This year, even though the calculus students were JCS students who were familiar with doing math this way, I started with the standard curriculum. I didn't want to go through what we went through last year. It is a good book. There's some numerous good things in it, but it is the standard curriculum. After about 2 months, Jacine came up to me and said, "Bob, please don't make us do any more of this. It's so totally boring. Can we do Exeter?" Here's a student who was getting an A in calculus, could have crunched numbers the rest of the year, but he was willing to risk his grade on a program he knows is more challenging, but has substantially more reward. So that's a mathematician. I was really proud of him. So we went to Exeter 4C and finished the year. I think it's a great program. The kids are successful at it. A little bit of training up front, then they're successful. They like doing it, proud of themselves. Ton of fun to find solutions to these when you had no idea when you started exactly how to get there. We teach children the scientific method in science. I think we need to teach them the mathematical method in math class. And so I'm happy to offer the program and really enjoy working with the kids. So that concludes my remarks, because I'm going to get back to this. I've got an idea about the volume.